some of your observations. The first thing I want to talk about is symmetry. Did you notice some symmetry in all of these graphs? Yes, excellent. If there was a sine of theta or sine of some sort of theta, if there was a sine in your equation, what kind of symmetry was there? Vertical? Vertical says pod 1. Do we agree or disagree? These kinds of things work better if you participate. Agree or disagree? Agree? So vertical? Okay, sine we think of associated with y. Y is our vertical variable. Anytime you see a sine in your equation, you know you're going to have vertical symmetry. Okay? If there was a cosine in your equation, what kind of symmetry was there? Horizontal symmetry. X we think of as the horizontal variable. X is usually associated with cosine. Okay. Now, the section 3 is what we're going to talk about on Thursday, so don't worry about what those graphs look like. Right now, I want to focus on section 1 and 2. Section 1, what kind of graphs did you see? Circles. They were beautiful, weren't they? There are actually 3 different ways to make a circle, 3 simple ways to make a circle in polar form. One of them was not on this sheet. We talked about one of them yesterday. Yesterday, what did our circles look like in polar equation form? I think we had the example x squared plus y squared equals 16. And we changed it to polar form. R equals whatever, right? We have like R equals 4. Okay, if we have R equals a number, where's the center of that circle? What? Oh, that's not sense. Where's the center of that circle? The origin, we're going to call it the pole. And A represents the radius. Okay. Now let's talk about the circles that you graphed in section 1. If you had a number times cosine of theta, where was that circle in relation to the origin? Pod 2, where was it? A number times cosine of theta. Where did that circle go? Okay. So it was symmetrical about the horizontal axis, like we talked about in the last slide, and it went to the right. If A was negative, where did it go? It went to the left. Okay. Now A is what distance in this circle? Okay, this time A is this distance, the diameter. So, pod 5, help us out. If we had R equals A sine theta, where does that circle go? That would be you, lovely ladies. Oh. And if A was negative? That was very helpful. Okay. So here is A sine theta. If it was negative, we would have to flip it down, right? So we still have that symmetry about the vertical axis. And A is representing the diameter. These should be the easiest of all of the graphs, your circles. Okay, did you have a question? Okay, we're going to get there in like 2 minutes. Okay? First of all, this is what you're going to see every single time you have to graph a polar graph for me. You're going to see, because we're going to do worksheets for all of these graphs, so you're going to see a blank grid, and you're going to see all of these things, okay? So we have -5 sine of theta is r. We know that what shape is it? It is a circle. We know that, and based on section 2, there's not a coefficient in front of theta. Okay, it's just 1 theta, and so that's how we know it's going to be a circle. All right? Our max R value, okay, let's first just talk about what that circle is going to look like. Justin, based on what we discussed on the previous slide, where is that circle going to be in relation to the pole?
Below.
Below, and that 5 is giving us what?
The radius. Or, yeah, the radius, right?
The radius? Okay, Justin thinks it's the radius, but he feels unsure.
Yeah, sure.
What, Shelby? Shelby says diameter.
Oh, okay. That would be more correct.
You feel better about diameter?
Yeah, I would say 2.5 would be the radius.
Okay. So below the pole, we have a circle of diameter 5. So that's a terrible circle. I'm really sorry. The 5, since that's our diameter, that is the furthest we're away from the pole. That's what we consider our max R value. Okay. Max R value, when are we, or how far is the furthest distance from the pole? Okay. Now, if we were to graph this, okay, when we graph polar equations, we plug values in for theta, and we figure out what R is so we can plot that point. So much like we would with like an XY, we like to start at theta is 0. Okay? If we begin at theta is 0, what is our R value? What? -5. Agree or disagree? But she thinks it might be 0. So which one is it? -5 or 0? 0? You change your mind? Sine of 0 is 0. All right? So we begin, anytime R is 0, that means we're at the pole. Okay? If we were to plug in, let's just say, pi over 2, and we plug in pi over 2 to theta, what is our R value? Honor, what's our R value? -5. So when we are at pi over 2, we go backwards 5. Hey, there's that point, right? So we've drawn this part of our circle, okay? Let's say we plug in pi. What's the sign of pi? Zero. So at pi, our R value is 0, which means we are back to the pole. Okay. Now, I want to talk about what this means right here. Zeros. When we talk about zeros in X and Y, we talk about where we cross the X-axis. Okay? That is not the case here. When we talk about zeros, we're talking about when R is 0. So when are we crossing the pole? Okay? So in our chart, we began at 0, 0, and then we ended at pi 0. So this graph has 2 zeros at theta is 0 and theta is pi. Because at 0 and at pi, our R value is 0. Does that make sense? Whenever our R is 0, that's considered a 0. We're at the pole. Okay, it has nothing to do with an axis. It's just about the pole. Awesome. Let's talk about roses. These graphs are called roses when we have that coefficient in front of theta. Now circles can be, these circles can be grouped in with roses, but I kind of like to separate them, okay? So let's talk about what you wrote on your gold sheet, okay? We've already talked about the symmetry piece. If it is cosine, we have horizontal symmetry. If we have a sine, we have vertical symmetry, okay? So pod 3, can you tell me anything about what A tells us?
A determines the length of the diameter.
The length of the diameter?
Yeah.
Could you be a little more specific what you mean by diameter? Like we have what we call petals, right?
Of the length of each petal.
Okay. So pod 3 says length of petal. How many of you would agree with that? Anybody disagree with that? Okay. I would not say that since it's not a circle. So like over here when we have like max R value, I think that's what you're trying to describe, and that would be a good way to put it. It's the furthest we're going to be away from the pole, and that would be a good way. Okay. But for right now, I'm just going to keep length of the petals. I think that's a great way to describe it. Or furthest we're going to be from the origin. N. Pod 1. What does N tell us? Okay, N for number. That's nice. Number of petals. Do you agree or disagree with pod 1? Number of petals. Okay. Was it a hard, fast N is the number of petals you have? It's not, is it? It got a little confusing for some of us, didn't it? Okay. Pod 2, tell us what happens with N. And why is it just not?
If it's odd, then it's
Okay.
but if it's even, then it's
Double that. Okay, this is what Shelby just described to me. Do you agree with what Shelby described? Okay, so if that coefficient is even, we have to double it, and that's how many petals we're going to have. If it's odd, that's the number of petals we're going to have. Now, what's kind of strange about these is really we're always doubling the number of petals, but when the number of petals is odd, or when that coefficient is odd, those petals overlap, so we only see 3 petals. There's really 6 there, but we only see 3 of them. Okay? What's actually going to happen is when we have an odd number of petals, it's only going to take us from 0 to pi to draw all of those out, while if we have even petals, it'll take us from 0 to 2 pi to draw all of the petals. Okay? Not a huge deal if you remember it or don't remember it, but it may be helpful to some of you who like to see patterns like that. Okay? So you're going to get the same setup here on all of your graphs. Graphing these roses will not be the most challenging part of these problems. Probably finding zeros will be more where you're going to see more of your work. Okay? But figuring out what kind of rows we have and number of petals, okay, that should be pretty straightforward now that we've gone through this activity. Okay, so we're going to do 2 examples, if not 3. We'll see how much time we have, but for sure we're going to do 2 examples. Odd number of petals, even number of petals, sine and cosine. Okay, so here's our first one. We'll start with a cosine. Cosine ones are nice. Remember I do have that graph paper if anyone needs to grab it. Okay. So first of all, shape, obviously it's a rose, but I do expect you to put how many petals we have. So, Tayson, how many petals do we have? We have 3 petals. Because of that number right there. Alright? Madison, how long are each petals? 5. That number is 5, so our petals are 5 in length. Okay? Now we know this is going to have horizontal symmetry, but what you're going to need to do, no matter what the graph is, you always need to begin by plugging in 0 for theta. Every time you gotta plug in 0 for theta. Alright? So when we plug in 0 for theta, what do we get for R? So 5, 0 is our first coordinate. Okay? And since we have that coordinate way out when R is 5, we know that that's one of our petals, right? One of our petals has to come out to there. Do you agree? Okay. So from here, we can draw our graph. We have 3 petals that has to span over this circular grid. How can we figure out how far apart these petals are going to be? There are 3 petals. Very good, Justin. There's 360 degrees sitting in front of you. And we know those petals have to be spaced evenly apart. So if we cut that by 3, we know our petals have to be 120 degrees apart. So if we have a petal at 0 degrees, then we have a petal at 120 degrees, which would mean our next petal would be at 240 degrees. Okay. So now, are you ready? We're going to draw our graph. And as you draw your graph, first of all, make sure you start at theta is 0. So whatever point you wrote right here, that's where you have to start. And as you draw your rows, you need to count how many times we go through the pole. Because how many times we go through the pole will tell you how many zeros we have. So are you ready? Wait. Okay. Are you ready to count with me? So how many zeros do we have? 3. Okay, now I traced it like this, right? It really doesn't matter how you trace it as long as you start in the starting point. Some of you guys are going to go like this, right? You're still going to get 3 zeros out of the deal. I'm always going to trace it the way that I know the calculator is going to trace it, but it doesn't matter which order you trace it as long as you start at that starting point. Okay? So we have 3 zeros. How do we find our zeros? Do you have an idea? No? We need to plug something in. What did I tell you being a 0 meant? It's where what? It's where R equals 0. So what could we do? We can plug in 0 for R. So R needs to equal 5 cosine of 3 theta. Excellent. We have a trig equation to solve. It's a good thing we've done this before. Okay, so let's solve this. We can divide by 5. So 0 equals the cosine of 3 theta. So we have the cosine of an angle equals 0. Right? Kira, when is the cosine 0? Okay, so that means 3 theta needs to equal pi over 2. But how many zeros do we have? We have 3 zeros, which means we need to list how many numbers right here? 3. So cosine of 0 at pi over 2 and 3 pi over 2 and if we keep rotating, say louder.
No, I might be wrong.
It's okay if you're wrong.
5 pi over 2.
You are not wrong. 5 pi over 2. Okay. So now how do we get theta? Okay. If we divide by 3, theta is pi over 6, 3 pi over 6, and 5 pi over 6. So those values are our zeros. If you leave it as 3 pi over 6, I won't count it wrong. So as far as your significant points go, I definitely want when theta equals 0, and I'd also like you to put your first 0 in there. As long as I have your first pedal and your first 0, the rest you're going to draw by symmetry. Okay? And I don't need all of the other points. I only care about what's on the graph. But I do want your first pedal and your first 0. Okay? Any observations to make here? Any observations to make here? How many pedals did we have? 3. Is there anything interesting to anybody up there? We did have 3 zeros. Okay. Keep that in mind. Next. So we have a rose. How many petals? Would there be? What?
That's the coefficient.
The coefficient? Okay. So we have 2 different coefficients, right?
Yeah.
Which one of them gives us the number of petals?
The one in front of the sign.
Is it? Isaiah has a question. Is it the one in front of the sign? Joe says it's the one in front of the theta.
That's probably right.
That is probably right. So let's go with that. If you think that is right. How many petals do we have?
4.
Do you agree? Okay. So it's the coefficient in front of the theta, Isaiah decided. And since it's even, you doubled it. Is that what you did?
Yeah.
Okay. Our max R value. How long are each of our petals? Sarah, how long are they? 4. And you got that from coefficient in front of the sign. Excellent. So now we need to start on our graph. Where do we begin? At theta is 0. Every time, theta is 0. Leave your zeros for very last. We're not going to touch those ever until we've graphed it. All right? Okay. So when theta is 0, what is our R value? Hmm? 4? 0 R is 4? Two times 0 is 0. What is the sign of 0? 0. 0 times 4 is? Okay. So we begin at the pole. Okay? What is unfortunate about that is we have no idea where our first petal is. Just drawn in. How could we figure out where to place our first petal? What do we know about our petal? At all the 90 degrees?
Like along the,
Okay. What was that? Cosine or sine? Do you remember? Because weren't we playing when? Because then I had you playing around with cosine for that sheet. Yeah, I had you playing around with cosine. Okay, and this one's sine. Okay, so we're only going to have a petal on the horizontal axis if it's cosine because we have that horizontal symmetry. Okay, so that's just something to keep in mind. What do we know about each of the petals, though? What's our R value? 4. Okay, so if our R value is 4, then we'll know where we have a petal. Is that logical? If R is 4, we have a petal, right? Okay, so let's solve this equation. If I divide by 4, that means 1 equals the sine of 2 theta. Where is the sine equal to 1? Good. So pi over 2 is going to equal 2 theta, which means our angle is what? Pi. Huh? So at pi over 4, we have R is 4. So there's our first petal, okay? Every time you have a rose petal with the sine function in it, you're going to begin at the pole, and so you're going to need to do some calculating to figure out where your first petal is. Now, the more you do of these problems, maybe the better you're going to be at figuring out where these petals are going to be. Some of you are going to notice some patterns, and you're going to have to do less calculations the more you do these, and that's fine. All right, some of you may have to do that every time, okay? So now we have 4 petals. How do we figure out how far apart they are? Okay, we have 360 degrees to divide into 4 petals. So each of these are 90 degrees apart. So if we're at pi over 4, then we're at 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, let's count how many times we go through the pole. Where do I begin? The pole. So let's count. What do you say? 2. 5. How many of you thought we were going to have 4 zeros? Why do we have 5 zeros instead? Because we started at the pole, okay? Your sine rose curves will always begin at the pole, so you're going to have an extra 0, okay? And like I said, you notice how I drew it kind of funky? If you draw it like this, which I assume a lot of you are going to want to do, that is totally fine. You're still going to get the same number of zeros, Okay. So now let's find our zeros. How do we find our zeros? We take 4 sine of 2 theta and we do what with it? Excellent. So if we divide by 4, 0 is sine of 2 theta. Right? So now we need to decide where the sign is 0. Josie, where's the first place sign of 0?
0.
Okay, so 2 theta equals 0. How many of these do we need to list?
5.
5. So first place is 0. Next place? Pi also is in there, isn't it? And 2 pi. And pi over 2. At pi over 2, we're at the coordinate 0, 1. Cosine sine, I think the sign is 1 there. Right? So 0, pi, 2 pi, 3 pi,
4 pi.
4 pi. I can just dance for you here.
27.
Any multiple of 5, right? So, but we only need 5. There are our 5. So now that's what 2 theta equals. So we'll take all of these and divide by 2. So our zeros are 0 over 2, pi over 2, 2 pi divided by 2, 3 pi divided by 2, and 4 pi divided by 2. All right. What do you think? How about these graphs? Zeros you save until last. You always begin when theta is 0. Remember, your significant points, I only need 2 of them for rose curves. Your first 0 and your first petal. So here we have our first 0. Here we have our first petal. That's all I need you to write down. And then the rest, you go by symmetry. Okay? We have 7 minutes. I can do an additional example, or I can give you your worksheet. Is 2 examples enough? You wouldn't mind either one? Okay. Are 2 examples enough? I will let you get started.